Welcome to Last Minute Maths, and in this video we're going to be covering the Edexcel May 2019 Paper 1, which is a non-calculator paper and higher tier. And as usual, as we work through it, I'll include revision tips for every topic as we go along. So each question can act as a small revision for that particular topic. One difference, I'm going to actually do this one in real time rather than preparing it ahead of time. So let's see how that goes. And do check out the other videos on the channel. You'll find lots of other papers worked through and topic videos, revision topics and so on and so forth, and some science videos as well. So do check them out and I hope you find them useful. All right, let's get down to the questions themselves. Question number 1. What do we have? Blue cubes, red cubes, yellow cubes in a box, and they've sort of like told us how many there are in a sense of probability rather than the actual numbers. All right. Now, the important bit of information they give us is that the number of red cubes equals the number of yellow cubes in the box, so the same number. If you have the same number, it means that they have the same probability. So equal probability. Probability. And the other rule that we need to remember, that when you have different events, the probabilities of all the different results, all right, must add up to 1. All right. So the probability for the red and the yellow must be 1 minus the probability of the blue, which is 0.2, therefore total 0.8, and the 0.8 is obviously shared by the red and the yellow equally because they have the same probability, as we've said. So therefore 0.8 divided by 2, 0.4. So the probability of each one of those, red, 0.4 and 0.4. And that effectively adds up to 1, so we know that that's correct. All right. Now they're saying that you've got 12 blue cubes in the box. All right. And work out the total number of cubes. Okay. We know from the information in that table there, okay, that if blue has a probability of 0.2 and red has 0.4, then the number of red cubes must be double the blue. Same with the yellow, must be double the blue number. So effectively what we have, it's blue, red, and yellow. So if blue is 12, red must be 24, and yellow must be 24. And so when you total those up, you've got 60 altogether. So the total there, 60 cubes in the box. All right. All right, moving on to question number 2. One of those recipe questions. You've got 50 grams of sugar to make 15 biscuits, all right? And then it says she also needs 3 times as much flour and 2 times as much butter as the sugar. So straight away, 3 times as much flour as the sugar. So 3 times 50, 150. And 2 times as much butter as sugar. So fairly simple, 100. All right. So that's how much you need for 15. Okay. If you want to make 60 biscuits, is what the question is saying. So 60 divided by the recipe that we have so far is 15. I want effectively 4 times the amount of the ingredients for the 15 biscuits. All right. And the one that they want the quantity for is the flour. All right. So we know that for 15, we need 150. So for 60, we need 4 times 150. And that actually comes out to be 600 grams in total. All right. So 600 there. And then Dion has to buy all the butter she needs to make 60 biscuits. So in this one, we need to find out how much butter first, and then work out how many packs, because it says each of the packs are 250 grams. All right. So remember, it was 100 grams for 15. So 100 grams for 15. So therefore, 4 times 100 for 60 equals 400 grams. All right. And if it's 250 grams per pack, therefore need 2 packs, 500 grams will be enough. All right. So the answer is 2 packs. Right. Question number 3, highest common factor. Here's where we do a prime factor tree. All right. And there are different ways of laying this out. I mean, you can do it as a little tree or a cascade, ladder form, etc. And I'll show you the format. So 72 divide by the prime factors. Okay, it's an even number, so the first one we're going to try is 2. That leaves us with 36. 2 again gives us 18. Divide by 2 again, and that gives us 9. Divide that by 3, and it leaves us 3. There we are. So effectively, 72 is made up of 2 times 2 times 2 times 3 times 3, etc. All right. And then 90, doing exactly the same thing. Okay. So 2 leaves us with 45. And that one's going to be, let's say, start with 3. 15. Divide by 3 again. And you're left with 5. All right. So 90 is made up of 2 times 3 times 3 times 5. Okay. The way to work out the highest common factor is to lay out the results, if you like, pair them up. Okay. And bear with me, I'll just explain this. So 72 is 2 times 2 times 2 times 3 times 3. And 90 is 2 times 3 times 3 times 5. All right. Well, the way we find the highest common factor, it's actually the product of all the common factors, as the title says. So in this case, let me use a different color. We're going to pair up ones that are common. So there's a 2 and a 2 there. Okay. The other 2's here have no corresponding 2's in the 90, so leave those alone. Then we have a pair of 3's, like that, and another pair of 3's. Okay, so the highest common factor in this case is going to be, count this one as a 2, that one is a 3, and that one is a 3. All right, 2 times 3 times 3 is 18. Okay, so the answer there is 18. All right, I hope that method made sense. Number 4. Tidy that a bit. Okay. Number 4. It shows this diagram. All right. It shows a plan, front and side elevation of a solid shape. Okay. And it's on a centimeter grid. Now that's important in the question. Plan means from top. So from above, if you like. Probably a better way to describe it. Right? And front and side is obvious. Okay, so effectively what we have here, if you can picture this, is an upright cylinder. Okay, and the dimensions are what? You've got the diameter is 4 centimeters across, and which is true for here, you can see. All right, and the height is 5 centimeters. So all you want to do is draw a simple cylinder. where the radius is 2 centimeters and the height is 5 centimeters. That literally is all you need to do, is draw a rough sketch of a cylinder. Plenty of space to do it in. You can do that as big or as small as you like, but bigger the better. Right, question number 5. And I'm going to zoom out a little bit on this one, just to give you a clearer picture of what's going on. It says shape A can be transformed to shape B by a reflection in the x-axis, all right, followed by a translation of CD, right? Translation means move, okay? And remember that the top one is always X and the bottom one is always Y, all right? Okay, let's see what happens when we first reflect it in the X-axis. So zoom back out again and let's see what we can do. Okay, so reflecting A in the X-axis, that point is going to end up, as you can see, it's 2 from the X-axis. So we're going to flip that over and it's going to go 2 down. So that point will be there. Same with this other point, the vertex on the right-hand side. That will flip all the way down, exactly the same pattern that way there. And the tall side here, as you can see, is 3 squares tall. So from there, we're going to go down 3 squares down from there. Right, I hope that made sense. There we go. All right, so that's our intermediate. From this reflected shape, all right, let's call that R for a moment. So shape R now has to move across, and I'll show you what happens here. Has to go 1, 2, 3, 4. Okay, now because it's going to the left, that is actually minus 4. Okay, because it's heading towards the negative X. All right, and then it also has to go down. Right, so that's minus 1. So effectively, your CD is minus 4. CD is minus 4 minus 1. All right, that'll move it onto shape B. Putting that in. Okay. Right. Number 6. This is a lot of words for what is actually a rather simple question. So you've got different colored pens in packs, right? And each color, as you note here in the description of the question, 2 pens in the black pack, 5 in the red pack, and 6. So all of that information, you've got to make note of it, 6 in the green pack, all right? And on Monday, it says, the number of packs sold, here, here, and here, right, has a ratio of black to red to green of 7 to 3 to 4, all right? So this is a ratio of the packs. So the way we're going to do this is that we know that the black, the red, and the green, the packs are sold in 7, 3, 4 ratio. And then we have to use the information of the number of pens in each pack, all right? And so in the black, we know that the ratio of pens is 2, and red is 5, and in a green pack we have 6, all right? So therefore the total number of pens, I better just make this clear. Packs, pens per pack, and so therefore total pens, okay, with the black it's just 7 times 2, 14, and with the red 15, and the green is going to be 24. All right, and we then know that this is only the ratio, remember, Okay. And we know that the total number sold was 212. All right. And the total number of the ratio here, 14 plus 15, 29 plus 24 is 53. So divide the 212 by 53, and that turns out to be 4. All right, you've got to be able to do that kind of bit of mental maths, or indeed work it out, long division if you like. All right, so basically we've got 4 lots of everything. So the question is asking for the green pen sold, and so the green pens are 24 times 4 lots. All right, because we're scaling everything up to 212. All right, and so that's going to be 96 green pens altogether. All right, so 96. Okay. If anybody has any questions on the methods used or alternative techniques, then please do leave it in the comments, and I'll be very happy to respond to those. All right. Question 7. We have some information given about 2 shapes, 2 rectangles, and here we're told that QR is 10, all right, and BC, all right, this one here, is the same as PQ. So the rectangles actually have sort of like a common measurement. Okay, one end of it, they have the same measurement, but the lengths are different. Okay, we're going to label that X. Let's call that X. So they're both going to be the same. All right, let me rub that out. Okay, X. All right, and what it then says, the perimeter of ABCD is 26. You'll see that there. And the area of the other one, okay, is 45. We can straight away use that information, okay, because we know that the area of PQRS must be the length times the width, all right? So call that 10x, 10 times x, all right? And that apparently equals 45, all right? So therefore, x must be 45 divided by 10 equals 4.5 centimeters. So we have one dimension already, all right? And now, it says find the length AB, okay? We're going to call that AB length Y. All right, let's call that Y. So when it comes to perimeter, it says the perimeter of ABCD equals 26, all right? We now know that x equals 4.5, all right? So remember, as you go along a perimeter, you'll have in a rectangle 2 of each side, all right? So what that means is 26 equals 2 times 4.5 plus 2 lots of y. In a rectangle, opposite sides are the same length, all right? So 2 times 4.5 plus 2 times y. 26 equals 9 plus 2y. Take away 9 from 26, so what have we got? 17, okay, and that equals 2y. Therefore, y must equal 17 divided by 2, 8.5. All right, so the answer is 8.5 centimeters. Remember the properties of rectangles and perimeters. That's the main point of that particular question. All right. Okay, moving on. Number 8. It says work out an estimate. All right. So that means you're allowed to round the numbers to something that's more convenient to solve. All right. In this case, you can do it 2 different ways, I suppose. Easier to write it like this, I think. Using your knowledge of surds, and there is a short video on some practice surds questions. on the channel, so do check that out if you need to. All right, so 63.5 in this one, and that one's going to be 101.7. Let's start doing our estimating stuff. So round these numbers. Easiest one for 63.5, let's round it to 64. And 101.7 can be rounded to 100. And they actually present us with very easy square roots. So square root of 64, 8, times square root of 100, and that's 10. And so the answer is, as an estimate, 80. All right. You could have actually done that within the brackets and tried, for example, rounding first and then multiplying out, and done that and gotten that. All right, that's also possible if you want to go down that route instead. Both valid. Right, next one, part B. They've given some information initially and said 2.3 to the power 6 is 148 to 3 significant figures. Fair enough. And says find the value of 0.23 to the power 6. All right. So we need to express 0.23 as some form of a multiple or an adjustment of 2.3. So that actually equals 2.3 divided by 10. All right. So therefore, 0.23 to the power 6 is the same as 2.3 over 10 all to the power 6. All right. And we can treat those separately. All right. So 2.3 to the power 6 and 10 to the power 6. We already know 2.3 to the power 6 is 148. And 10 to the power 6, you can do this in two ways. You can actually say 10 to the power 6 is a million, so 1 with 6 zeros after it, and divide it that way. Or you can treat it like this. 2.3, rather actually, let me reverse that. I was going to get rid of that one. 148, if you like, times 10 to the power minus 6, because you're dividing by 10 to the 6, all right? And that means you move the decimal place 6 times. All right, so that is 148, and you go 1, 2, 3, 4, 5, 6. Decimal place goes there, 1, 2, 3, all right? And so on. So if that makes sense, that's one way of doing it. Or you can just put 148 over a million, and you come up with exactly the same answer. There we go. All right. Only one mark, so there shouldn't be that much working involved. And finally, there 5 to the power minus 2. Now, with a negative power, remember, a negative power means you flip it upside down. And I've got a whole video on the law of indices, if you want to check that out later on. Flip the number upside down. So, for example, if you flip 2, it becomes half. If you flip 3/4, that would become 4/3, etc. All right. So in this case, the negative power means we are going to put 1 over 5 squared, and that's 1 over 25. All right. There we go. And just to mention, laws of indices video, if any of you want to use that as a revision tool. Okay. Right. Next question, number 9. Very similar to a question in the previous paper I did. And with these ones, you can see you've got mixed numbers. All right. Before you can actually work with fractions in terms of actually multiplying, dividing, adding, subtracting, etc., the best thing to do is to change them to improper fractions, do the particular calculation, and then change it back to mixed numbers if necessary. Okay, so the first one, 3.5. So you multiply the denominator by the whole number and add 1. So that's 3 times 2, 6 plus 1, over the original denominator. That's 7 over 2. Oops, sorry. Let's tidy that up. I can do better than that. 2, all right? And same method with the second one, 1 3/5. So you put 5 times 1 is 5 plus 3 over 5, all right? So 8/5. And then when you multiply that, you've got 7 over 2 times 8/5. So let's just make it simple, I suppose. 56 over 10. And you can divide both by 2, 28 over 5. And now you want to turn that back into a mixed number. All right. So 5 into 28 goes 5 times, which is 25. And then 3 left over. 28 minus 25. 3 left over, 3/5. All right. So the final answer is 5 and 3/5. Okay. Question number 10. All right. Don't be put off by these nasty looking equations, simultaneous equations, right? Because it's on a grid. It's already on a grid for you. So you don't have to plot it and you don't have to work out the equation of the line, etc. Okay. And I'm going to say straight away, as I've done a complete revision of simultaneous equations. So do check that out as well if that helps. Okay. Right. In this question, it's actually much, much simpler than you think. When it says find estimates of the solutions of the simultaneous equations, all it means is the point where the lines intersect. Okay. Oops. Right. That is simply, you can see the point there. All right. All you want to do, and I'm going to enlarge it just a little, see if I can do this. And, oops, sorry. And you can see that that is roughly there. Okay. And going across, again, it's just over the small circle line there. So, I don't know, what do you want to call that? It's somewhere between 2.2 and 2.3, right? Just in between. And over here, it's a shade over 1.3, so minus 1.3, and the next bit is minus 1.4, all right? It doesn't matter, they haven't specified as to what level of accuracy they want, at least one decimal place. So I suspect if you were to put in 2.25, all right, let's try that, and minus 1.35 or even 1.3, it seems closer to 1.3, I suppose. So minus 1.3, that is sufficient level of accuracy. All right. Yeah, I think that's perfectly sufficient. Okay, question number 11. All right, you've got stem and leaf type question or data, etc. So let's see how we're going to handle this. Recorded the ages and years of the people on coach A. All right, so they're all ages, and coach A and then coach B. All right. Now, Luckily, they don't actually ask you to do a stem and leaf on this, but the method's exactly the same. So there are 23 people on coach A, and you want to find the median, low quartile, upper quartile. Remember, the median is exactly the middle value. All right. The lower quartile is roughly, you're saying, when I say roughly, what I mean is you take the median and then you halve it again. Okay, so that gives you a quarter. So the middle is, let's say, half. Then the low quartile is a quarter. The upper quartile is halfway through the upper half of the median, the upper half of the data. All right, so that's 3/4 of the data. Okay, so if I have 23 data points, the middle one is actually going to be 11. All right. Oh, sorry, bear with me. 12. Because you have 11 below it and you'll have 11 above it. All right. And so that would add up to 23. So if we count along, you've got 41, 42, etc. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right. So that's your median value. And you notice where that is. That's exactly 11 data points below 59 and 11 data points above 59. Okay, so the median value we've just shown is 59. Okay, the lower quartile is actually going to be, if you like, the median of the lower half. All right, so of these 11 that are below 59, again, go for the middle one. All right, so from 11, the middle one's going to be 5 below, 5 above, so it's going to be number 6. 1, 2, 3, 4, 5, 6. All right, so can you see that there are 5 above it and 5 below it? So that's almost like the quarter value, if you like. So that's 53. And because of the way the question's been laid out, made very easy for you, the same thing for the upper quartile, it's going to be the midway point in the top half of the data, above 59. And that again is the middle one, right? 66. I hope that's made sense. I'm trying to do it in a rather brief form. And if you have any questions, please do leave it in the comments, and I can either respond in the comments or I can do a separate video on medians and lower and upper quartiles, etc. Okay, so we've completed the table, and then you've got some information on ages of people in Coach B, all right? And before we even go into the question, straight away we can see that the median is higher, okay? And the interquartile range, as it's called, now for A, that is 13, right? 66 minus 53. And for the, so IQR, that's called interquartile range. Bit of revision for those of you who've forgotten this. Okay, so the IQR for Coach B is 73 minus 54. 19. Okay, so it actually has a larger interquartile range as well in Coach B. Okay, and the other information that we could use is, remember, the range. All right, that would give us the range. And same with that there. So the range here is 38, and this one here is 43. Okay, so the question says, Richard says that the people on Coach A are younger than the people on Coach B, all right? And the answer to this, is Richard correct, all right, is actually yes. And the main reason for that is the median, all right? So let me explain that. Yes, because the median in coach A is, and let's just put that thing there, 59, and in coach B it is, oops, sorry, pen playing up a little. It is 70. All right, so lower in coach A. Now, the meaning of the median is that the median marks a value where it splits your people exactly in half. So half the people are younger than, half are younger than 70, yeah, for the median. And the same statement for coach A, half are younger than 59. So generally speaking, the people in coach A are actually younger, right? And that's the main reason for it. Fine. And then there's one more part of the question, part C. Richard says that the people on coach A vary more in age than people on coach B. So this time you're looking at varying more. So varying more means more spread out. All right. And again, is Richard correct? Well, let's take a look at the data again. Okay. You can see that the range in coach A, right, is 38, and the range in coach B is 43. So straight away, the ages of the people in coach B are more spread out than in coach A, so they vary more. Okay, and the thing is also verified by the interquartile range. Okay, that the people in coach B have a higher interquartile range than in coach A. Both of those measures, range and interquartile range, both show you how spread out the data is. All right. So in this case, Richard is not correct. Okay. Both the range and interquartile range, and I think you are allowed in the spec for Edexcel to write IQR, the marker. Examiner will interpret that. Both the range and IQR are lower in coach A, and I think that's actually enough. I'm not going to complicate that anymore. It's only worth 1 mark. All right? Okay. Let's move on. Question number 12. The volume of these 3 spheres is what they're talking about. So you've got a sphere P, Q, and R. They're getting progressively bigger. The volume of sphere Q is 50% more than the volume of sphere P. All right. Now, this is now really important. Okay. Just a little revision on percentages. Oops, percentages. All right. If I have 50% more, that means I've got my original 100% plus another 50%. So that is a total of 150%. All right. And 150% as a decimal, okay, is 1.5. Okay. If you want to convert a percentage to a decimal, divide by to decimal, you divide by 100. Okay, so 150 over 100, 1.5. Okay, so we know that the volume going from P to Q we have timesed by 1.5, all right, going that way. Fine. Then, now a lot of people I think would misread this question, because what it's doing, it's saying that R is also 50% more than the volume that we had in Q, all right? And that's the really important bit here, okay? Pay attention to that, because whatever the volume of Q is, we're timesing that by 1.5 again, all right? So if we call it the volume V in P, all right? So you've got V, and then for Q, you've got times 1.5, all right? That's Q. And then we're timesing that whole thing again by 1.5, all right? So that's 1.5 again. So what they're now saying is that, or if you want to do it the other way, that is V times 1.5 times 1.5. A simple calculation on the side, if you like, just multiply it out by hand, is actually 2.25 of the original volume, all right? So if you want to turn that either into fractions, whichever way you want to do it, let's show you what's going on. So the volume of sphere P as a fraction of the volume of sphere R, P was my original V volume, and the volume of R is 2.25 V, all right? So the V's cancel. All we want is a fraction, 1 over 2.25. What do we do to this to make it into a proper fraction, all right? Well, we can see we have 2.25. Remember, 0.25 is the same as a quarter. If we want to turn that into a whole number, we have to multiply top and bottom by 4, all right? So that becomes 4, the top, and the bottom is 4 times 2 is 8, and 4 times a quarter is 1. That's 9, okay? 4/9 is the fraction represented by the volume of P over the volume of R. All right, move on from there. Next question, number 13, is a proof type question, all right? Prove that that number n squared minus n is never an odd number, and given that n is not less than 1, all right? So first thing we do is factorize this. We can see we have that, right, from n squared minus n. Now, let's examine this. Whatever number n is, right, n minus 1 must be the consecutive number below it, yeah? So, if n is odd, then n minus 1 is even, okay? Because they are consecutive numbers, one after another. Okay, numbers. So if n is initially odd, right, n minus 1 must be even. The number below it must be even. And you have an odd times even equals even. Okay. Now, if n is even, then n minus 1 is odd, and we have the same result. So, always even. There we are. It's as simple as that. Right, number 14. Now, this one, I'm going to write out a couple of notes. Again, I've got a trigonometry video available. It's a little bit more advanced than this, but you are expected, and I'm going to write this here. must know trig values. Something I've been saying to my students for years to memorize this, and unfortunately nobody ever does. So please don't make a mistake. Memorize them, and I'll show you how simple it actually is. All right? And you just have to know these following values. So the principal values that you're expected to know are for 0, 30, 45, 60, and 90. All right? So sine values, 0 is 0. For 30 degrees, it's half. For 45, it's, I better do it the proper way, apparently, root 2 over 2. 60 is root 3 over 2. And 90 is 1. All right? Now, the trick is, for cos, you actually do the sine values backwards. Okay? That means 0 gives, cos of 0 gives you a value of 1. Cos 30 is root 3 over 2. All right? And cos 45 stays the same, root 2 over 2. And cos 60 is a half. And cos 90 is 0. So given those angles, sine and cos are actually just reverse, put them in reverse order. Okay? And then finally, tan is the same as sine divided by cos. All right? So if you don't want to memorize them, you can actually work them out. If you've written out the first two rows, divide the sine value by the cos value. All right? And so tan is 0 divided by 1, 0. 30, it's half divided by root 3. So the 2's cancel. So it should actually be 1 over root 3. But if you rationalize it, then it becomes root 3 over 3. Okay. 45 is, as you can see, the sine and cos values are the same. So the same thing divided by itself, 1. And tan of 60, root 3 over 1, if you cancel out the 2's there. So that's just root 3. And for 90, you can't divide a number by 0, so it's undefined. We call it infinity, right? Or just ignore that. You won't get that in your GCSEs. But you must know these trig values. Okay, that's expected knowledge now. So therefore, we've got tan 30 times sine 60. That's the same as we can see here, root 3 over 3. And sine 60 is root 3 over 2. So what we have is root 3 times root 3 is 3. And 6 equals a half. All right. There we go. Right. Yeah, I can't impress upon you how important it is to know your trig values. So please do use that table and try and memorize it. Practice writing it out a couple of times. All right, number 15. And this one is not as bad as it looks initially because they've given you all the formulas you need, the volume of a cone and the volume of a sphere. All right. So they've given the data you need. Height of the cone is 10. The diameter of that base circle is 6. So the first thing you need to do, really important, is say that the radius equals 3. Okay? The radius of that base circle of the cone, and indeed the radius of this hemisphere, all right? It's, because it is a hemisphere, it's all the way same around, so it's got to be 3 as well. All right? Okay. So what do we have to do? It's given all that information, so that's fine. The total volume of the shape is k times pi cubic centimeters, where k is an integer. They want us to work that out. Okay, the first thing we do is volume of the cone, all right, which is going to be, let's see, using the formula they've given us, 1/3 pi r squared h, all right, and we just want to put the numbers, substitute the numbers into there. So 1/3 pi, r is 3, so we have 3 squared, and the height is 10, all right? So tidying all that up, 3 squared is 9, and divide by 3 leaves us with a 3 on top, times a 10, 30 pi, all right? And that's cubic centimeters, if you want to be absolutely perfectly accurate. And then we have the volume of the hemisphere, all right? So remember, that's a half sphere. Okay, the volume of a hemisphere is going to be half times 4/3, as you can see the formula here, 4/3 pi r cubed, pi, and then r again is 3, so 3 cubed. Okay, so what does this give us? Half times 4/3 is actually 2/3 times pi, and 3 cubed is 27. 27 divided by 3 is 9, and so the whole thing simplifies down to 18, right? Pi centimeters cubed, right? I won't bother with the units. And therefore the sum of the two, 30 pi plus 18 pi, 48 pi, and so k equals 48. All right, done. Not nearly bad as it looked initially. All right, number 16. 3 dials on a combination lock, and the numbers can be 1, 2, 3, 4, and 5. You can see there. The 3-digit number 553 is, for example, sent, so you can repeat the numbers here. All right, each one can hold any of those 5 values. So what it's saying, work out the number of different 3-digit numbers that can be set for the combination lock. So in this case, you've got a choice. There are 5 positions. You've got 5 for the first one, 5 for the second one, and 5 again for the third one, right? And that basically gives us 5 cubed, 125. That's 125 combinations, all right? Now, the next bit is, how many of the possible 3-digit numbers have 3 different digits, all right? If you're going to have 3 different digits, it means no repeats, or no repetition, if you like, all right? So you can't have the same number twice. So in this case, again, if we look at the 3 positions, the first one you can have any number. That's 5, all right? But the second one, whatever you've chosen for the first one, you can't have the same number again. So the choice is reduced by 1, all right? So it becomes 4. And then the final one, you've already chosen 2 numbers already, so you're only left with a choice of 3, okay? So the total there, 5 times 4, 20, times 3 are 20, all right? And that's all you needed for that question. Hopefully that makes sense, all right? And so 20 there, got it. Okay, given that, number 17, given that x squared, a ratio to 3x plus 5 is 1 to 2, okay? The best way to write this out and to actually solve the problem here is write it as a fraction, if you like. So x squared over 3x plus 5 equals 1 over 2. And what you can then do is cross multiply. The other way that I prefer to do this is if you have x squared to 3x plus 5, and then the ratio of 1 to 2, all right? You cross multiply that way. So it doesn't matter which way you write it, you have to cross multiply, okay? And exactly the same result this way. So using that method, what we're going to do is say that 2x squared equals 3x plus 5. All right. Let's move everything to one side. So we get 2x squared minus 3x plus 5 equals 0. And we're going to factorize this as a quadratic. Now, again, I'm not going to labor the point on this because I've got 3 different videos on factorizing quadratics. Okay, so videos. So please refer to that if you need to, all right, and revise the factorization methods. So what we're doing here, the first one, we know we want it in 2 brackets forms. 2 is a prime number, so it can only be made up of 2x times x. Similarly, the 5, right? Oh, I've made a mistake. Must apologize. That should be a minus. The minus 5, again, can only be made up from a 1 times a 5, right? And it's a negative, so it's going to be minus 1 times 5, or 1 times minus 5, all right? And given that the middle term is minus 3, I'm going to put the 5 here and the 1 there, all right? So that's going to be a minus 5, and that's going to be a plus 1. Why? Because when you multiply that out and you double check it, you'll find that 2x times 1 is 2x, minus 5 times x, 5x, gives you minus 3x, all right? So if that's the case, then we have 2 statements. 2x minus 5 equals 0, so x equals 5 over 2, or x plus 1 equals 0, so x equals minus 1. All right, so I hope that's fairly self-explanatory. X is 5 over 2, x equals minus 1 are the 2 values that you need for that. All right, okay. Quickly on to number 18. Surds, again, as I said before, there's a Surds video in my channel that I've done, so check that out if you need. And for this one, all we're going to do is convert everything into the sort of like simplified surd version. So root 12 is the same as 4 times 3, so root 4 times 3. That effectively is root 3 plus root 4 is 2, and then you're left with a root 3. So that actually comes as a total. It's 1 root 3 plus 2 root 3 is 3 root 3. All right, nothing too complicated. Okay, and this bit I'll just explain what I've done here. It's splitting it up, root 4 times root 3, so that is 2 times root 3. That's where that came from, all right, in case anybody's confused. Right, this next one, the power applies to the numerator and the denominator, all right, so that's the same as writing 1 to the power 7 and root 3 to the power 7, all right, so that's simply 1. 1 to the power 7 is 1. Root 3 to the power 7, remember that root 3 squared equals 3, all right? Now, in this case, we've got root 3 to the power 7. So each pair of powers, if I want to describe it like that, results in a 3. So that effectively is going to be 3 times 3, remember it's power 6, so 3 again, all right? And times root 3. Okay, so the whole thing is coming to 1 over 27 root 3, okay? And we need to rationalize. Okay, rationalize. So if you rationalize this, you want to multiply top and bottom by root 3 again to get rid of the root 3 in the denominator, all right? That one there, That's the one we want to get rid of. So effectively what you have is root 3 on the numerator, and then you've got 27 times root 3 times root 3, and that comes out to be 27 times 3, and there's a root 3 there, and that is root 3 over 81. All right. Okay, I hope that has made sense. There we go. Right, let's move on to the next question, number 19. And this one, those of you who are sharp-eyed and alert will see straight away that that is a completing the square question. All right. And again, I've done a nice detailed video on completing the square for quadratics and the techniques, right? Even for the more difficult versions. So please, again, do check that out if you need to revise that. All right. So, okay, with completing the square, what we're doing, you start with that. You want to turn it into like what's called a completed square, right? So you halve the middle number, the second coefficient, the coefficient of x. All right. So what we're going to do is turn that into x minus 3. So you've got to look at the minus 6, halve it, and that's what goes inside the brackets, right? So x minus 3 all squared. Then you have to minus this minus 3 squared. So I'm going to write it like this. Okay. And then you have the original plus 1. All right. So minus 3 all squared is 9. All right. So bear that in mind. X minus 3 all squared minus 9 plus 1. And that whole thing comes out as minus 8. All right. So A is minus 3 and B is actually 8. Now watch out. They've put minus B. Okay. And here you've got minus 8. So the B is just 8, not minus 8. All right. So careful. And then the second part of the question, it says, hence write down the coordinates of the turning point of that graph. Remember that when you have something like this, and call it minus b plus b, whatever you want to call it, right? Like that, okay? The turning point is actually given by those values a and b. That's actually exactly what it is, all right? So it's going to be 3 and minus 8, okay? The point I want to make here, and it is actually in my other video, is that this one, change the sign. Okay? And this one, same sign. Stays same if you like. Okay? And just remind ourselves what the final version was. X minus 3 squared minus 8. So the minus 8 stays as it is, and the minus 3 changes to a plus 3. Okay? Right. So 3 and it's minus 8. There we go. Right. Proceed as quickly as we can. Try and wrap this up. Question number 20. H is inversely proportional to P. So inversely proportional means 1 over. H is inversely proportional to P. That gives us a formula that says H equals K over P. And then we have another one. P is directly proportional to the square root of T. So, like that. And that again can be turned into, now this time, instead of using K, I'm going to use a different letter, just so that we can keep them separate. All right. and that is square root of t, like that. All right, and we've got a set of numbers that we can use to work out what those k's and m's and all these things mean. All right, so the first one, let's work out the h and therefore the k. When h equals 10, right, p is 6, therefore 10 equals k over 6, k equals 10 times 6, 60, all right, so we know that. And then when p equals 6 again, we've got the same detail, t equals 144, p equals 6 again. So for this one, 6 equals m, and the square root of 144. Square root of 144 is 12, so m equals 6 divided by 12 equals half, all right? So if we now use all that information, okay, we know that p equals half square root of t, and we can replace that in the h formula. So we have the k, which remember is 60 over p. Replace it with this, okay, and that equals 60 over half square root of t. All right. Now remember, we're dividing the 60 by a half. So how many halves are there in 60? That comes out to be 120 over square root of t. So the final formula is h equals 120 square root of t. All right. I hope that makes sense. Again, any questions on that, please do leave it in the comments. All right, almost there. So the first one we need to do for functions, question 21. You've got these two functions given to us. Okay, so the first bit, part A, is to find the inverse function of x, so inverse f of x, all right? So with this one, we're going to say y equals, let y equal 3x minus 1, right? So y equals f of x. Then we want to rearrange it and try and get x on its own. So you get y plus 1 equals 3x. So y plus 1 over 3 equals x, all right? And now swap. Yeah, you're not going to write that in an exam, but just put swap y and x. So that effectively gives you y equals x plus 1 over 3, all right? So x plus 1 over 3, all right? There are other techniques for doing that, but either follow whatever your teacher's given you or use a simple method like that, right? Whichever you find most easy to understand. Okay, then we have this statement, f g of x equals 2 g f of x, right? This thing I am going to explain. I've got, again, a video on functions. Okay, so there is a short functions video. Revise that if you need to. All right, sorry, get back to blue. So what do we do? All right, f g of x actually means this. You put x into g first, and then whatever the result is, you put that into the function f, all right? So we know from here, g of x, okay, is x squared plus 4. So g of x equals x squared plus 4. That whole thing will now go into the function f, all right? So f of that is effectively f of x squared plus 4. And remember, f of x is 3 times x, i.e. whatever you put into it. So it's 3 times that whole lot, x squared plus 4, and then minus 1. Tidy that up, 3x squared. 3 times 4 is 12 minus 1. So 3x squared plus 11. All right. So that's fg of x. All right. So now we want to find g f of x. Okay, so this is step 1, if you like. Step 2, g f of x. We do exactly the same thing as we did before. We put the result of f of x into g. So f of x gives us 3x minus 1. So we want g of 3x minus 1. And g is whatever the input is, x squared plus 4. So that is going to be 3x minus 1. That's our input. Square it and plus 4. So we need to work this thing out now. All right. And just verifying that thing there. So let's expand that. Okay. 3x minus 1 all squared is 9x squared minus 6x plus 1 plus 4. All right. That is 9x squared minus 6x plus 5. Okay. And I'm just going to quickly summarize that. You know, when you do the 3x minus 1 times 3x minus 1 equals, remember that, and then this times that. So you've got to multiply each element by every other element in the other bracket. So that is 3x times 3x. So actually, you know, let's do that. 9x squared. And then you've got a minus 3x minus another 3x. And then finally, minus 1 times minus 1 is a plus 1. Okay, just to verify that result, if in case I've skipped too many steps there. All right, so now we want to go back to the original statement that they've said. Fg, all right, Fg of x equals 2 times g of x, g f of x, sorry. All right, so Fg we know is here, 3x squared plus 11 equals 2 times that second result here. All right, so 2 times 9x squared minus 6x plus 5. And let's jump into this as quick as we can. So plus 10 there, so minus 12x plus 10. And tidy everything up. So you got 15x squared. And what have we got? The 12x stays as it is. And you've got a minus 1 there. All right. And what the question was saying is exactly that. Right. See here. Okay. And we have exactly that. All right. So that's done. That probably is the most complicated question so far, in my opinion. Right. And back to this last one here. Okay. What do we have? This one takes a little discussion, and I'll try and finish this as quickly as possible. There are only red counters, so R red counters and G green counters in a bag. Okay, so the probability the counter is green is 3/7. Okay, then they put everything in the back again, so you're starting from square one, and they're adding 2 more red counters and 3 more green counters. Then the probability of getting a green changes to 6/13. All right. Now I'm going to interpret all of that. You've got to put it all into a simple mathematical sort of format. Start with the first statement. A. All right. A. The probability of getting a green is the number of green, okay, over the total. The total is green plus red. Okay. And we're told that that probability is 3/7. Okay. Now, in this case, for this second statement here, right, part B, what it's saying is that 2 more red counters. So the number of reds now becomes R plus 2, and the number of green becomes green plus 3. So G, right, those are your reds. And then you've got G plus 3. All right. So now the total has become R plus G plus 5. And that's your new total. And the new number of greens is G plus 3. So in statement B, the probability of getting a green is G plus 3 over R plus G plus 5 equals 6/13. All right. Similar to what we saw earlier on in the ratios, we're going to use exactly the same sort of cross multiplication. So this first one, scenario A, you got 7G. Remember, I'm cross multiplying, right? In both cases, like that. And so what we have, 7G equals 3 times G plus R. And so I'm just going to go straight and do that. Okay. And the other side of that, I'm trying to think what's the best way to do this actually. Yeah, that should be fine. So we have that, and then we've got 3 times G plus 3, so it's 3G plus 3 times 3 is 9, and the R plus G plus 5 times the 6, so 6R plus 6G plus 30. All right. We are going to use A, so it's like simultaneous equations again. All right. So let's just put that in. Simultaneous. Okay. Right, almost there. So we're going to use this scenario A, the first equation, and we can see that you got 4G equals 3R, all right? And we want value for R and for G in the question, all right? So what are we going to do? We're going to say that, for example, G equals 3/4 of R, all right? And in the second one, again, I want to tidy everything around. So we've got, what are we going to do with this? Let's see. Okay. So 6R, let's put a 0 there, shall we? 6R plus, yeah, 6R plus 3G equals well, plus 21. All right. Right, I've just spotted what I've done wrong here, actually. I covered that with a 1, so let me correct that. And my apologies to anybody who's been following intently and I've misled them with that statement. It's 13G. It should be 13 times that. And I was being a little bit blind, unfortunately. And the rest of that was fine there. Plus 6G plus 30. All right. And if we rearrange that now, instead of what I did earlier on by missing out that 1 there. So, excuse me, 13G. Let's put that there, shall we? So 13 minus 6, 7G there. And put 6R. That's as it is. And you can have a minus 9 there on that side. All right. So remember, G is 3/4 of R. So 7 times 3/4 of R. 6R minus 9. And so what we have is 21 over 4. And that's R. And 6R minus 9. So just extending that out now, we can express the 6R in terms of 4 as 24 over 4, all right? So 21 over 4 minus 24 over 4 that's R, equals minus 9. So negative numbers on both sides, no problem. So minus 3R equals minus 9. And therefore, R equals 3. And 9. Right, so now we have a base value for R. We then have to work out what G is, right? G, remember, equals 3/4 of R, which is 3, right? So 9 over 4. Now, here's a revelation. You've got that is not a whole number. So that means the numbers have to be scaled up, all right? You have to scale them up until you make them whole numbers. So with this one here, right, it's got a denominator of 4. So times both numbers by 4, right? So G equals 9, and R is going to be that times 4, 12, all right? So the original number of counters in each of those, red was 12 and green was 9, all right? So that was a little bit of a trick. Why that is the case is that up top, where they gave the ratios, or indeed the probabilities, you're dividing one by the other, and it actually sort of cancels out or reduces it down to simplest form, right? So there may have been a factor that's been cancelled out, which you can't see. So if we do come up with one of those, right, in normal simultaneous equations, the fractional answer is okay. But since this is like whole counters, all right, you've got to have integer answers. So please do make sure you check that. All right. Okay. Hopefully that's made some sense to you and been a little helpful if you followed through that. There are plenty of other videos on there, and I'm doing more every day, so please do watch them if it helps you. And do consider subscribing and liking, put a comment in. Any questions you have, anything you want explained further, leave it in the comments. I would welcome that, any suggestions you have. And otherwise, thanks for watching.